Hello everyone, welcome back to my channel. In today's video, we are going to explore a really interesting device, the Lux Meter. Have you ever wondered how bright your room really is, or if your plants are getting enough light? A Lux Meter helps you measure exactly that, the intensity of light. I'll be showing you what a Lux Meter is, how it works, and how you can use it in your daily life. So we start with what is a lux meter? A lux meter is a tool which is used to measure brightness or the intensity of the light with which it is perceived to the human eye. The unit of measurement for brightness, or more precisely lightning, is the lux, and it consists of two components, instrument and sensor. Here you can see in the figure, this is the lux meter and it consists of two components. This is the instrument and this is the sensor which is covered. The surface area across which the light is dispersed, which influences how bright it appears, is taken into consideration by the lux. So 1 lumen of light distributed over 1 square meter is equivalent to 1 lux. So what is 1 lux? 1 lux is 1 lumen of light distributed over 1 square meter. And lux meter consists of a photocell which converts light energy into electrical energy, which is recorded in the form of lux. After the light is converted into an electric current by the meter, the gadget may determine the lux value of the light it is caught by measuring this current. In this slide, we will discuss the principle on which the lux meter works. So the lux meter is based on the principle of photoelectric effect. That is, when any light falls on a photosensor, it generates electric current, which is directly proportional to the amount of light received. That is, photosensor detects light and generates electric current proportional to the amount of light received. Now, this entire process takes place in four basic steps. That is detection of light, conversion to electrical signals, that is conversion of light energy to electrical signals, signal processing, calibration and display. So in the very first step, that is light detection, the sensor will detect the incident light and the current output will change with light intensity. Then the second step is conversion to electrical signals. The change in current is converted into measurable voltage signals. Third step is signal processing. The voltage signal is amplified and processed by the lux meter's electronic circuit. The last step is calibration and display. The processed signal is calibrated against a known light source and displayed directly in lux units on the meter. The key components in the lux meter are photosensor, amplifier circuit, microcontroller or the analog circuit, and display unit. Photosensor will detect light and convert it into an electrical signal. Amplifier will boost the weak signal from the sensor, and microcontroller will convert the electrical signal into a lux reading, which will be displayed on this LCD. That is the display unit, which shows the illuminance value in lux. Now, photosensor which are used in lux meter are of three types, basic three types, which are used to detect light intensity. And the most common are LDR, that is light dependent resistor or photoresistor. The second one is photodiode or the silicon photodiode, and the phototransistor. These are the three basic photo sensors which are used in lux meter. So the basic lux meter uses LDRs, that is light dependent resistor. The professional lux meters use silicon photodiodes, and phototransistors are used where moderate sensitivity with low cost is needed. So the LDRs are made from cadmium sulfide. The more the light, lower will be the resistance. Cheap, easy to use, but it has a disadvantage. Its response is very slow, less accurate, and does not match human eye sensitivity well. Now comes silicon photodiodes. They convert light directly into electrical current, fast and accurate, often corrected to match human eye sensitivity. Now, what do we mean by often corrected to match human eye sensitivity is that is when we use a photodiode to measure light. We usually want the output to represent how bright the light appears to the human eye. Now the problem is that a photodiode and the human eye do not respond to the wavelength the same way. So we correct the photodiode response using either an optical filter shaped to the eye's sensitivity. So this is why it is mentioned often corrected to match human eye sensitivity. Used in high quality lux meters, lab equipments and industrial light measurement. Phototransistor, similar to a photodiode but with amplification, more sensitive than a photodiode but less accurate in spectral response. Now what do we mean by less accurate in spectral response? Is that in phototransistor the spectral response is less accurate, meaning it does not represent real optical power consistently across wavelengths. That is, when the wavelength changes, it does not show or indicate the correct wavelength. Used in automatic lighting systems, consumer light sensors. Now, the procedure, how we will use the lux meter. Firstly, we'll ensure that the batteries are properly installed and the sensor, that is the photocell, here it is covered with the lid, should be clean and free from dust or fingerprints. This is why a lid is given, so that it is covered and not unnecessarily exposed. Know the units. Most meters measure in lux, that is lumen per meter square, and some can switch between lux and foot candles. Now we'll set the range. If your meter has manual ranges, into 1, into 10, into 100, start with the highest to avoid overload, then lower it for accuracy. So we'll set it at the highest, and then as we will find the range, we'll decrease it to lower values for accuracy. In the previous slide, I told you that we'll set the range first. So now let us discuss in detail what do we mean by setting the range. So what actually happens is that if we don't know the value we are measuring, we should start with the highest range first. Because if we'll start with too low, the meter will show meaningless results. We can see here. See, I selected the lowest range. The area is the same in both the pictures, and the light intensity is also the same. But when I selected lower range, that is into 10, the meter is showing, lux meter is showing value 1. And when I increase the range to 100, you can see here it is written into 100 lux, then it is showing 720. The same area, the same light intensity, but in the lower range the value is 1 and in the higher range the value is 720. So what should we do? We should start with the highest range first, and then we can switch down to a lower range to get more precise and readable value. And now these are range multipliers. We simply multiply the reading with these range. They do not change the value which is depicted on the screen. Now we can see here the range setting and the meaning. If it is into 1, it means the reading is directly taken. If it is into 10, we multiply the reading by 10. If it is into 100, we multiply the reading by 100. And if it is 1000 or 1k, we multiply by the reading that appears on the screen by 1000. Setup and positioning. How we will position the sensor. We'll power on the lux meter, place the sensor at the exact location and orientation where light needs to be measured. For general illumination, it should be horizontally placed at the working plane, and for vertical surfaces, the sensor should be vertically facing the light source. If you do not place the sensor correctly, the readings may vary. So the position of the sensor is very important for the correct measurement or the correct reading. Now we will understand how to measure using lux meter. So you can see in this picture this red button, which is the power button. We will press power button to turn on the meter. So the meter will be turned on. Then we will select the desired range, that is into 10, into 100, into 1000, into 10,000. So we'll select one of these range, and we have already discussed in the previous slide that selection of range is very important. If you will select a lower range, the meter will show meaningless readings, as it was in the previous slide where we selected the range into 10 and the meter was showing into 1 and the meter was showing the value 1, which means that it is overloaded and the range needs to be increased. And as soon as we increase the range to into 100, it started showing 720. So we have to choose the desired range, and which is by default 2000 lux range in this. Now we will, here you can see this is sensor. So now we will open the sensor cover, which you can see in this picture, it has been opened, and this white sphere is the sensor which was covered in the previous picture. So if it will be covered, it will not show reading because the sensor will not capture light to be converted into lux readings. Now as soon as the sensor was opened, that is the lid was removed and the sensor was exposed to the light was captured and it was converted into lux readings. So now read the measurement result on the LCD. You can see here. And if only 1 is displayed on the top digit, it means overload and the higher range should be selected. Once the reading has been taken, we'll press the hold button, and as we press the hold button, a symbol H appears on the screen, which means that this value will be held and will not change unless and until we exit the hold mode. To exit the hold mode, we'll have to again press the hold button and then this H symbol will disappear. So if the measurement is completed, we will again cover the sensor, light sensor, with the lid and press power button to turn off the meter. We can repeat this procedure for n number of times in the similar way and note down the readings at different places. Now, in the next 2 slides, I'm going to show you the practical demonstration of how to use Lux Meter. This is the Lux Meter, and the Lux Meter is used to sense the brightness or the lux of any environment. It consists of 2 parts. This is the instrument and this is the sensor. Now in this instrument, this is the LCD display and these are the buttons. You can see the power button, which is used to turn on or off the meter, and the meter will enter dormancy mode if there is no measurement in 20 minutes. That is, if you switch on the power button but you do not take the reading for 20 minutes, in 20 minutes it will enter dormancy, and then you need to again press the power button to restart. This is the hold button. Hold button, when we press the hold button, a symbol H will appear on the screen and the current value will be held. That is, the hold button is used to hold the current reading. And this light sensor is that when we uncap it, we see a white sphere. This white sphere is actually the light sensor, and it needs to be cleaned when we are taking measurement. So this is all about the instrument. Now we will see how to operate it. Now we will learn how to use this instrument to capture the light intensity. So first we will switch on the power button, and this is the range. So by default 2000 is range is selected, and it is showing value 0 because the sensor is closed. So we uncap the sensor and we see the reading increases to 25. So this intensity is of the surrounding. Now I press the hold button. Alphabet H appears on the screen, which means that this reading will be held and it will not change even if we cap the sensor or we uncap it. So after that we will press again the hold button so that it comes out of the hold mode. Now we will take the sensor under a bright light and you can see the reading is changing, but as it uh, goes below the very bright light, the reading appears 1. Now what do we mean by 1? That is the instrument is overload. That is the range we have selected 2000 is less. We have to select higher range. So now suppose I select 20,000, even then it is coming 1. So it means we need a higher range than 20,000. We select 2 lakh and then you can see the value appears 630. It is 100 times. So 100 times. And now if I remove it from the light source, under the light source, you see the value decreases, and if I cover the sensor, the value again becomes 0. The value becomes 0, and this is how we take the reading, and then we can switch off the power and close the instrument. In the previous slide in the video, we have seen that even when the lid was closed and it was under the bright light, it was showing 001. Why was it showing 1? Because the range was not decreased. The range was high, that is in 200 lux. So it was showing 1, that is a meaningless result. Because if the range will be high, very high, or if the range will be low, then the meter will not show the correct value. Hence, even when the lid was closed and the light intensity was very high, the value did not become 0, it was showing 1. Now we will record the data after the reading has been taken. We'll note the lux reading, time of the day, and time of the day becomes very important if we are studying the natural light, and the location where it was measured, whether it was in the room, outside the room, in the open area, under the tree. So we'll note down the location and then the type of the light source. Then besides the different precautions we have discussed so far, at the very end after the reading has been taken, we'll turn off the lux meter and clean the sensor gently with a soft cloth if required, and store the meter in a protective case to prevent damage. Now, how we will evaluate the results? So we'll calculate average illumination, that is indicated by E, average. So we'll take the readings E1 plus E2 plus E3 up to n number of readings we have taken. Suppose we have taken 5 readings. So then we will divide. So E1 plus E2 plus E3 plus E4 plus E5 and divided by 5. So we'll get the average. Now we'll check the uniformity. Uniformity is E minimum upon E average. And the ratio should be of E minimum divided by E average should be either 0.7 or higher is usually acceptable for workspaces. Lower values indicate uneven lighting that can cause eye strain. Now we will discuss this formula with the example that if we measure and we get lux values as 400, 380, 420, 390 and 410. So how we'll find the illumination, average illumination? We'll add all these values 1, 2, 3, 4, 5 and divide it by 5. We'll get 400 lux, which is the average value. And the minimum reading is, you can see here 400, 380, 420, 390 and 410 lux. So 380 is the minimum reading. And what is the formula? Uniformity is equal to E minimum upon E average. So the minimum is 380 divided by 400, which gives us the value 0.95 uniformity. And what did I tell you? I told you that the ratio of 0.7 or higher is usually acceptable, and values lower than 0.7 will indicate uneven lighting. So here our value is 0.95. So what does this indicate? It indicates that this value, as this value is greater than 0.7, it indicates uniform lighting, which is acceptable. Now, how to interpret lux readings? Lux reading help us to determine whether an area has adequate illumination for the type of the task to be performed. We can do that by comparing it against standards, and we can also identify whether the lighting is uniform or not. But the most important thing, that lux level alone does not guarantee visual comfort. To prevent glare, lighting must be controlled in terms of brightness, direction, uniformity and reflections. Now these are the recommended values at different places, location and unit in lux. For example, in school, in the auditorium or in the indoor gymnasium, the light intensity should be in 100 to 300 lux. Inside the classroom, it should be between 200 to 750. Laboratory or in the library, between 500 to 1500 lux. So in the similar manner, in the hospital, at various locations, the lux values are given. In the store, at different locations, in hotel, in the factory and in the office, different locations, and the value or the intensity of the light in lux is mentioned. Now, what are the practical tips to be followed? Avoid placing our body or anything between light source and the sensor, because that will give incorrect reading. Take reading under steady conditions. That is, light should not be flickering or the source should not be moving, and the person who is taking the reading should also be stationary, should not move. And for daylight studies, we should observe the sky condition and the window orientation. Repeat measurements at regular intervals if monitoring over time is to be done, over a duration is to be done. What is its applications? Architectural lighting design, that is to ensure adequate illumination in buildings. Then industrial and laboratory measurements, measuring light levels in production or research environments. Photography and cinematography, optimizing exposure settings. Environmental studies, monitoring daylight levels. Museum and gallery lighting, preventing light damage, agriculture, monitoring artificial light in greenhouse. These are the various applications of the Lux meter. So in this video on Lux meter, we have seen that Lux meter is a simple but powerful tool for anyone who cares about perfect lighting. Like, share and subscribe. Thanks for watching. Stay tuned.